We need a round of applause for database one. Come on. We have for you today an incredibly awesome presentation from an awesome speaker, Ori Herrnstadt, he's the CTO of Akiban. Before we start this, though, we're going to start with a quick question and answer for the audience. The topic presentation today is about renormalization. So the first question is, before we go to renormalization, by a show of hands, who here knows what normalization is? Practically everyone. Okay. Who wants to throw out a description of what normalization is? Like a one-sentence description. Shout it out, guys. Someone? Otherwise, I'm picking on the people who had their hand up. You got it.
Structuring like data in stored common tables.
Yeah, that's it. Okay. Let's try for denormalization. Wait, do I have like prizes? No, sorry, I gave them out already. I should have saved a few pens. Do you want a pen? Okay, denormalization. Show of hands.
This one goes for a hand sanitizer.
That's a hand sanitizer. Okay, from one of the people who had their hands up, who wants to describe denormalization? Define it.
It's the inverse of normalization.
right on with the description. Anyone want to give the actual description of denormalization? The hint is that it's NoSQL related.
More like flat files.
More like flat files. That's pretty much it. Yeah, you store objects whole. That's pretty much it. Okay, renormalization. Show of hands. I guess I won't be querying the audience. Right? Renormalization?
Just as you expect, the inverse of the inverse.
Yeah. Great description. You would say hands. Okay. I got no more prizes. Alright, so I guess we'll start with, without any further ado. This is Ori Herrnstadt from Akiban. He's the CTO there, and this is renormalization from SQL to documents. Is that right? Close it up. Thank you.
Thanks, everyone. Thanks for coming. I would say thanks, New York. Thanks, Eric, for throwing this together. So what I thought is that I'll share with you a bit of my experience as a developer. And hopefully that will resonate with some of the experience that you guys have seen. But I thought we maybe condense it a little bit from, however many years to 4 days in the life of a developer. And go through what I think we all experience, or at least I have, which is you wake up this one fine, bright morning, and you have this brilliant idea that I'm standing in front of, and you know you're going to be rich. It's just so plain obvious that all you need to do is execute, and maybe they should just give you the check, because why delay? And then you wake up the next day, and the hangover is gone. The idea is still great, and you go, okay, so let's do it. So you set up your application, and if you really think about your applications, each one of you goes to go to wherever you work, and you think about your application, there's a few objects that you really care about in that application. And so you put them together, and you have a basis for an application, and you go, okay, now I need to actually put the data somewhere. Right? So default, use MySQL, get in front of it. Use some ORM, Rails, or whatever you happen to use. And it all looks great until you actually go ahead and implement it, and suddenly your objects that were so cool in the application explode into hundreds and hundreds of tables. You start wondering, why oh why? So what's that curse word, normalization? Why did it have to be this way? And I don't know if anybody has experienced this in the past. Hands? Yeah? I see a few nods and a few yes and a few hands. And that's exactly what we end up with. And obviously this is tiny, but you literally open your ERD diagram and you look at it and you go, okay, so I have 230 tables. What does that mean? And how do I get out of this? So experienced developers, you've been there before, you know that's not going to work. And so, what am I going to do? So, think, options. And how about less tables? I have 230, if I deleted 200 of them, no more problems. Well, almost no more problems. When was the last time anybody really deleted a table from an application that works? It just doesn't happen too much. So, how about denormalizing to materialized views? So here's denormalization, right? Flat table. So let's take all these tables and just put them in one table. It's so much easier, and that's just going to work. And reports are actually going to run really much faster, right? I mean, that's going to be super good, but what about your operational inserts and updates to the data? So now you have to keep those things in sync, and who knows how that's going to work. Would you mind taking away this slide?
Yeah.
Sorry. So the next thing that I've seen over and over again is, okay, so I got objects and they fall into all these tables, so why don't I just ignore relational for a second? Take whatever I have, serialize it, say it's PHP, serialize it into a PHP object, just cram it into a blob in the database and get it over with. I can get my object in a single request, I can put it in a single transaction, life is awesome until I want to create. And then it's like, okay, what do I have in there? My database became a key value store, right? So what do I do next? So how about caching, right? Kind of the same thing, but not really. And it works awesome. So you build your object, and that takes time, and that's annoying, and your ORM does it. But once it's there, finally, in your hand, just put it in the caching layer, and memcache is right there, and I've done it before, and boom, you can get the object right back in your hands, unless it changes in the database. And then you have to go and update, right, and refresh your cache and validate the data. Okay, so it works really well for static data, but for dynamic data, if you have an operational system that ladders, I don't know. Okay, so it doesn't work quite as well. So let's just drop the whole idea and go to NoSQL, right? That's the new kid on the block. And that's going to pretty much solve my problems. And to be honest, it's really, really cool. You can just take a JSON object, put it there. My personal problem, being a developer that had experience with large systems, was that it drove me nuts. Just like that. So I really know the value of SQL, but it drives you crazy. And you keep doing this spinning around trying to make it work. So let's rewind for a second and go back to that thing that we call a schema. And what I like about it is that this is a real schema from a real customer that I'll talk about in a second. But the schema itself is much, much bigger. This is exactly what happens when you put it on your ERD diagram. You throw it on the ERD. This is what you get. Here are all the tables. But really, when you think about it, your application has objects that got translated to this, right? If there was a way for me to capture that, to say, right, I had objects, they exploded into these tables, but the meaning of those tables is those objects. That's what they try to capture. And so if there was a way to do this, what is this? This, that would be cool. And that's called table grouping, which I'll talk about in a second. But mostly what I did here is just organize the tables so they have some meaning, right? So my objects are now there in front of me instead of like 200 tables and what the heck do I do with them. I'll show you guys more examples of this later. So I have two conclusions. First one is personal, which is I want a better SQL database. Second one was to go ahead and do it, which probably means that I wasn't completely in a good mental state of health, but it's been fun until now. This has been my ride. So what Akiban does is a database that is SQL, that can handle objects together as one and can scale. So to give you a sense of what that means, I'm going to go right back here. And this is not just a pretty diagram. What this is, what table grouping really means, is that we allow you to now take your database schema and describe the object that it really represents, right? Bring it back to, so I had my object in my application, they exploded, and now I'm putting them back together so they describe my object again, if that makes sense. So it's not just that logically I can group it, and I'll describe this schema in a second. It's also that physically, data is stored and processed in a completely different way while keeping SQL fully intact, in fact more powerful than ever before. So how do we do that? Well, say you have your very basic users and orders and items, right? Kind of very, very classic example. And you have three logical tables up there, which we recognize as a group. When we do that, we actually take the group and co-locate the related rows. So, for example, a user, Ari, sitting right here, thank you, will be co-located, his rows will be with his orders and with his items and with his logins and with his address and any other information related to it together. So it's almost like I took those three tables and I shuffled them together, right? I just put them together. There are still three tables. Logically, you see three tables. You see SQL, you see three tables. But physically, what I did is I rejoined them. I eliminated the joins, right? So now my user row is with all of its related rows together in disk, SSD, memory, process, whatever. So it's a different way of looking at it, and I claim it's nice, not just because I've been working on it for a while, but I think it's nice because it unites three things that I really wanted to achieve, which were get SQL to work really, really well. Get SQL to be powerful and for queries to work really fast. But I also wanted document-like access to my data. Not one row at a time like your regular ORM, like you're going to use one, that goes back and forth, right? If you want the user, then you get the user, and then it's related information, all the tables, and back and forth for each table. I just want to get my object, my document, my group, as we call it. And then I want to be able to scale it when I grow up. And in the next few slides, I'll just walk you through what we have done based on this kind of basic understanding that if your schema can be grouped in this way to a few main objects, and each one of those is stored and processed completely differently under the hood physically, then the first thing that we can do is get a document from a SQL database. And this is just a very simple example. So say I want users with their addresses and with all of the logins that they've done in the system, right? Usually that would be 3 queries going to 3 independent tables. But what this does is it allows us to write one query that brings that information from that group. It's already together, right? The user is already with his logins, with his addresses, with all of his other information. So it just allows me to get it. Oops.
Don't know what happened.
It's fine.
That works.
There we go. Yep. So what it allows me to do is to get back not a row, but a bunch of rows that actually describe an object. An object that looks something like this. From a SQL database, in a single request, in a single round trip. So I can get my document or my object from a relational database in a single request, or parts of it. And this can get arbitrarily powerful. So that was the first thing that was nice. The second thing that was nice was that SQL looks the same, right? We write the same SQL. Select distinct from tables, join other tables, predicates, where, group by, having, everything is the same. But under the hood, everything is different. Under the hood, I don't think about tables anymore. So if I have a query that looks like this, so select whatever from users, join with logins, join with locations, for all the users that are in location X and are in this case, active, order them by the latest time they logged in, this is usually a three-way join, right? Any relational system, MySQL or otherwise, will do this as a three-way join. But we don't. This is executed without a single join because users and logins and locations are just a part of a group, right? This is all stuff that belongs to users. So this query is much more efficient. Now if you go back, some of you have, 3, 5, 7-way joins, 10-way joins, 12-way joins. That becomes quite significant. If you guys have run complex queries, you know that they can take seconds, they can take minutes. What happens if your execution plan, your explain, is such that you don't have any joins that you need to execute? Or way fewer joins. So if this was the relational way, MySQL's way of doing it, it basically said, okay, for each table I'm going to pick an index, join those, so for some of them where the index is covering, bring the tables, put them in some temporary space and join them. What this says is a temp table, sort it, and output, right? Which is why a lot of companies just say, don't send queries against the database. Because this will just run for seconds and get the whole database low, and if I have 1,000 of these, they're going to be painful. Anybody experienced this before? I see a lot of noise. Okay, so the execution plan for us is different. Because I don't need to consider tables, I consider a group, and this falls within a group. And everything in the system is predicated to think about a group, from the storage to the execution engine to the optimizer to the interface. And so what that means is that we have one group index access. So indexes are defined as groups. Literally, it's, instead of a table as the main physical entity in the database, now you have a group of tables as a basic physical entity. And so this is the execution plan that you get, where, sorry, that's fine, stole my thunder, where you go to an index on the group. When you access the group, it gets you the user, but also gets you all the other information about the user, because it's right there with the user for free, right? So you just need to access the group, going all the way to projecting the results. And what's interesting is, if you compare this execution plan, you really look at it, it looks exactly like what a relational database would do for a single table access. So suddenly accessing a group is a group of tables. All of these 20 tables that describe your user is as simple and as efficient as a single table in a relational database. So suddenly complexity actually works. And then you get, for this specific query, what you see here are just numbers that show that sure, it helps you when you have one user in the system, but where it really becomes effective is when you start increasing concurrency, because you don't have to do all the joins, you don't have to do all the temp tables, all the sorting, and everything that goes with it. Your plans become much more efficient. You can do a lot more in the machine. And then there's distribution, which is all about, okay, so how do I take my data and scale it? It's really easy on a single machine, but how do I take it and take it beyond the single machine? And whoever has been in the database, in the relational database, especially field for a while, knows that it's a difficult problem. And we just look at it somewhat differently, which is, so I have these groups, and I'm going to fly back for a second. So I have this group, or these groups. So let's talk about them for a second. So this is a schema from a company that has professionals that they match with jobs that need to be executed. Okay? And there's a lot of information about professionals, obviously. What they've done, what kudos they received, what kinds of jobs they're allowed to do, how much they charge, all sorts of things. And there's a bunch of information about companies that look for jobs to be executed. And then what these guys do is, match those, put them together, like Match.com for professionals that can do jobs. And when you look at it, you go, okay, so I get how I can get this, my professional group in one place. I get how queries can work well. But how does it distribute easily? And the idea is that you can usually figure out that there's going to be a key that is a natural distribution key, almost like a semantic distribution key. So let's take some examples, which, one of them is multi-tenancy. If you've seen or been involved in applications do multi-tenancy, your tenant is almost like a natural distribution key, right? So if you're, say, 37 signals and you're doing high-rise, right? There's a bunch of users in each of those. Do you guys know high-rise? Anyone? 37 signals? Yeah? Cool. So what you see there is that you can actually naturally cluster users that work within the same project. And you can use that as a key. So we can use that key to cluster all the related users by space. We add that as a special key to this group. But that's just the first step. The second step is you can now take that same idea of clustering related information and take clusters and put them in different nodes. So if you have different groups of people doing different projects, then you'll cluster by project, and each project will go to its own independent node. And that's really the idea of how distribution works, and it's really about leveraging the semantics. So I'll give one example. Probably get back to this. So this is another example. This is a company that handles students and student information for schools. And there's two interesting things that I'd like to show here. The first one is that their natural semantics of the data, the natural distribution of the data goes by district, which kind of makes sense, right? The student is in a district, one or another. And so what they did is they took up there in the person table, they took a district ID and they distribute the users, the people that they have, to the different districts. And different districts sit in different nodes. The other thing that's nice to show here for anybody who's dealt with ORMs before is that one of the problems with ORM is inheritance, right? If you want to model inheritance in a good way within ORMs, then that means that you're going to create more tables, which you don't want to do because then you'll have to join all those tables. So this company has exactly this problem where a person can be a staff member or a student or both. And they want to keep that information. But what it meant is that every time they dealt with a person, they had to join it with all of those tables. If he's a student, join with the student table and join here, and it became inefficient. What you're actually looking at is a single group. So they could get now a person with, if it's both the staff and the student, they can get all of that information in a single request. They can run queries on top of this, just like before, very efficiently, and they can distribute the data, these people, by the different districts that they're on. I'm seeing big eyes. And this is how they actually did it. What they did is added a clustering key. And this clustering key defines that distribution. I will probably give more examples later on.
Great. Can I ask you a question?
Sure.
Can you walk through an example where, let's say I want to make this distributed, I want this more efficient, and I want to find all the students that say are like 6 feet tall, or maybe that's too tall for students, but 4.5 feet tall. Or I want to get a distribution by height because I want to figure out what height to put the toilets.
So we've seen strange distributions, right? So that's a great question. You're doing it exactly the same way. So you define the clustering key based on what you want. So I'll give another example, but that one was good. Example that comes up a lot is temporal distribution, where you want every month to go to a different location, because most of your queries go per month. So for example, you keep adding information about something, and every month you want to say, okay, I have this batch of a month, and I want to go to the next one. And so you can define that as the clustering key. So the month being the clustering key. And that's going to take care of how data is clustered together and how distribution actually occurs based on this key.
What happens if you want to query on something that's not your clustering key?
Then you actually have to go to all the clusters to ask the question. So it becomes very efficient when you stay within the cluster. If you think about multi-tenancy, for example, a situation where you have multiple clients, each with a bunch of information, many times that's exactly what happens. So they want to ask information about, or to give you access just about your world, not about other world. But they can still have queries in the backend, reports that span all the data, and that will work just fine. So, I'm going to stop here and switch to, okay, so that sounds interesting theoretically. What does that mean? And what it means is that what we're trying to say is that SQL and relational modeling isn't the source of all evil. It's the way we've implemented it. And if we don't lose the information about your objects, you can get really powerful SQL, direct access to objects, and natural way to distribute your data from a relational system. And so we built a server, and it's called the Akiban server, which is a very creative name. It took us months to do it. And it's going to be open sourced later this year. And it has those capabilities that I mentioned. What we've also done from our hard-earned lessons is we've developed a way to plug into a MySQL infrastructure. So if anybody here runs his own infrastructure and he has MySQL and they run either, or you run either to queries that take too long because you personalize the data and, or for whatever reason it takes seconds to minutes, or you want to get the objects out but you find yourself denormalizing all the time. So we realized that we don't really have to tell people, okay, so what's your option? Throw away what you've done and start fresh. Because that's a pretty difficult thing to say. What you can do is just plug an Akiban server into your existing MySQL infrastructure as another slave to the MySQL application stream. So if you have a MySQL master and two slaves, you can take one of them, transform into Akiban, or just add a slave and redirect just the problem areas to here, and it's going to keep up to date just like any other replication slave. So it's a really easy way to start experiencing it. You just spin up a node, replicate, run the queries against it, see what happens, and go from there. So a lot of the initial engagements that we have, a lot of people who are using it for the first time, they'll go, here are my 5 worst queries. How do I know? Because I turned those slow query log, took it down to 1 second, and so a whole bunch of queries that are running slow. Pick the top 5 that are hurting me, and just redirect those, and see how it works. And then that works. Great, so now I can take the next batch of problem queries, and I can start thinking about, okay, so what can I start doing with this tool that's now at my disposal without throwing away your existing infrastructure? Hold on. Okay, no, that's fine. Okay. So this is the architecture, and there's really one thing that I want to say about it, that is that the product is designed to be open source with additional components that we believe the enterprises would want and desire. Whereas the developer would get this and go ahead and play with it. Which is the main goal of tonight, and I'll happily go back to the architecture itself if anybody's interested. But we've been at this for a while and been working with design partners. These are companies that are using us alongside MySQL and just solving their most pressing needs, the most pressing problems right now. What we are in the process of doing. Oh, yeah, very nice. You can change the color on the slide. Real-time optimization. Yep. So the other thing that we're doing now is starting to give access to the server itself, the independent stack, to early adopters. And this is my personal focus right now. And we're looking for people who are interested in trying it out, kicking the tires, telling us what they find, what works, what doesn't, before we actually release it completely as open source. So I've already got a bunch of people interested. I hope to get a bunch more. So if anybody is, this is the email, and it pretty much goes to me and Ari. And we'd love to hear from you. What it means that we'll just, we release it in batches and just open it up in the next batch, and hopefully, and give you access to it, and you can kick the tires, see how it actually works, especially if you're already looking at different options. Really appreciate the feedback. And that's me.
So he doesn't have to change the color. That says O-R-I. Okay. Well, first off, I want to give a great big thank you to our exceptional speaker, Ori Herrnstadt. He is the founder and CTO of Akiban. Thank you. And I want to give a great big thank you also to our sponsors, Schooner Information Technology, Continuing, Scale-Based, Vork Enterprise Framework, and the greatest place in the world, the ladders. In terms of the ladders, there was a lot of talk about job execution. If anyone's been executed from your DBA job and are seeking a new job, by all means, come to either me or Andrew. There is a DBA opening. So that's a different kind of job execution, I realize, but hey, whatever. And now it's just, if anyone's got questions for Ori, yes?
My question is, what about other database in the platform like DB2 from IBM, or is working, or you don't have any issues with that, or you haven't support that yet?
We don't support that yet. Our clear focus is MySQL. So MySQL users who are right now running the problem.
In the future, you're planning to those things, or not?
I will smile and look at the business people from my company in the audience. Would we ever support DB2 or Oracle? I think
not in the short term. I mean, our focus is to really bring this technology to market as a truly independent database that you guys can work with as a relational technology in its own right. We also, along the way, think we can solve the problems for a number of large installations. We want to start with MySQL. It may go beyond that, but for the foreseeable future, independent to keep stack and MySQL.
Next one. Yes.
How about Microsoft SQL, MS SQL?
SQL Server?
Yep.
Pretty much the same answer. So we are, it's not that, I come from DB2 Oracle background. So, and I've built military operational systems, and you hit this all the time, which kind of explains why we're doing it. But we have to really, really stay focused. And in the MySQL community, this is so pervasive, and you get so much personalization work, especially on in all of the web companies that are coming out, that we've got our hands full. And so we literally pick a focus and are sticking to it until somebody convinces us otherwise. Yep.
Next question.
Which type of MySQL are you, which version of MySQL are you talking about?
So mostly work right now with backup. We're using 5.5.12. We can replicate from any 5.1, 5.5, anything that you're using. We haven't tested or support 5.0, which for, I think, obvious reasons. But
Can you tell us just a little bit of background information about your company, how long you guys have been around? And
sure.
Sorry.
Background information? Should I take?
All right. I mean, Ori founded the company based on this vision really back in 2008. We went out to, I joined him, I'm more on the commercial side, my name is David, CEO of the company. We went out and raised money in 2009, it was a bit of a crazy time, all the VCs were in fetal position, but we were actually able to raise our money and put our team together. So we've been going since 2009, and we're now at a point where we have a number of customers that are actually, have been working with us for several months and are putting us into production. So we're at that point with early adopters who are moving into production deployment. And part of what we're doing here is outreach to more of the developer community to start getting you guys more closely involved with the technology and have you kick it around and get feedback from you.
We're about 20 people now. Headquarters in Boston, office Boston. There are living pictures. And it surprised me as well at the beginning of there. It's actually Boston because it started at MIT and turned into a company more than it started as a company. So the main technical development team is in Boston. We do have some San Francisco base. And we are exactly at the inflection point where we have worked for a long time with MySQL users to get this stable into production. And we know that the next step is putting an open source release into developers' hands, which is pretty much becoming my main focus.
Before we move on with Q&A, just want to do a quick announcement also. Who's got the Kindle Fire?
Oh, that's right.
Want to talk about? Sure. We have a raffle for a really, really cool prize. Thank you, Akiban. We have a brand new Kindle Fire. If anyone's not familiar with what that is, it's basically a color Kindle, which is super slick. And it doesn't have any box. It has no good box. And you know what the greatest thing about these like tablets are? They all look exactly the same. I mean, it just looks like a tablet. But it is really cool when you turn it on. I'm not going to obviously ruin it for whoever wins it, so it stays in the package. But this is a Kindle Fire, I do assure you. And the actual raffle itself will send to everyone by email instructions on how to enter it, and everyone's got an equal chance. So that's cool. And Q&A. Who's next? Yes.
I was going to ask you
We'll do you next.
Oh, thanks. You talked about grouping, and to me that sounded a little bit like views. So, I'm sure they're completely different, but what's the difference? And I was wondering if you could also talk more about JSON and structure of Akiban.
Sure. The views are a logical construct, right? You're defining a pre-defined query that then gets run. It doesn't change the way the execution happens. Groups are a fully physical declaration. So they change the way data is stored. They don't affect your queries. The queries still work against tables. Does that make sense? So I'll take another step at it. Views are a logical thing because you can say define view and it's some query. And then you can run it. Then if it has join table A to table B to table C, that will still happen, right? It's just another way to kind of store a query for future use because you use it all the time, this segment of a query, right? That's what a view is. A group is more about how you actually store the data, like an index is about how you store the data, right? So it allows you to actually identify, I guess a little bit like you do in a view, identify those relationships, but have control over how data is stored. So at a fundamental level, it changes how query execution actually works. There was a question about JSON, so I'll get back to it later on.
On the same line, basically, then how different it is from indexing and doing table partitioning that Oracle does, for example.
Right. So, right, table partitioning is a great solution for your big table that you want to take and separate across tables, really, right? So you find, for example, 4 tables, and they're all exactly the same structure, and divide your big table between those 4, right? That's what partitioning does. Here, the situation is not that I'm trying to optimize the single table access. What I'm trying to do is take a schema. So when I come to operational systems, and been doing it a lot over the past year, you go to your schema, and you take a look at it, and there's 200 tables. And I'm not trying to optimize the query that says, give me something from this table, which is a lot of analytical systems would do, right? It's the fact table, it's huge. Now let me run well over it. I don't want to go there. I literally don't want to go there. I want to be able to run those queries on my operational, normalized schema without denormalizing, without creating these huge materialized views that just explode in terms of the data. So where I optimize is where you have multiple tables. Does that make sense?
Yeah, it does. But it sounds like clustering, similar to breaking down
I didn't hear it. Follow-up question. It sounds like clustering is similar.
So clustering allows you to take a small number of tables and put it together. It breaks down when you want to have multiple tables in that structure. So this, we literally encourage you to add as many tables as possible into this structure. Okay. I can give you a lot more insight. I've worked with this a lot.
So my hand right there. Yeah.
When you say you're kind of storing these groups together, what happens if, I mean, ideally a user is only part of one group, but what happens if you have the user table and you have orders and items, and then you have that same user table as part of a completely distinct group, like, I don't know, favorite groups and items or something? How does the storage happen there? Do you end up duplicating the data many, many times, or?
No data duplication. So the definition of denormalization is redundantly storing data from tables in multiple places to eliminate costs, right? To eliminate joins. That's why I talk about renormalization. Don't do it. And so we don't redundantly store data. I'm just going to show you a few examples from different companies. If you notice, we looked at this one before. If you notice, there were two groups. So why two groups? Why not one? Well, there are the situations where you have a many-to-many relationship, right? Which is the situation that you're talking about. And that's exactly what we're decide on taking aside. So this table, the one that matches professionals with jobs, could live with the professionals or with the jobs. So we decided that it will go in this group and be the separating line. How did we decide it? We looked at your load. We looked at what you do. We looked at your usage patterns. Because our goal is to eliminate, if this is your schema, right, and there's joins going all across here, my goal is to eliminate as many joins as possible in your runtime, right? So that's how I will actually group. I'll look at your usage pattern and optimize for that. And I'll just show you another example. Give me 1 second. So a few more examples are, I'll actually just give two. This is a dating website. And they have, if you really think about what they do, it's their users, right? They really care about the people that want to date. And they really want to know as much information about those people, because that allows you to find the other people in the best possible way. So they have a very rich object, which here it says user, and then a bunch of information related to that user. There's actually many, many tables related to that user. There are still other groups in this schema. So for example, regions, as they define them, is a different group. It doesn't belong in the same place. But what we usually see is that a schema, in general, even a large schema like this that comes from a gaming company, really falls into a few main objects, which takes me again up to your application, right? How many top-level objects do you really have in your application? And probably the groups will map those.
That person.
Yeah, I have a small question. Do we, like these groups are defined by the DBAs?
We will recommend, so literally give us your slow query load or just the schema, and we will recommend to you the DBA. Here's the recommended grouping based on what you give us. You are the final decider. So when we started, we thought, oh, we can do this fully automatic because we can watch your usage, and then we can, just change on the fly. We found two things out. One is schemas don't change that often, usage patterns don't change that often. The second thing we found out is that DBAs hate to be told. They need to be the ultimate control of what is going on in their system. And so they do. So we'll recommend, but it's up to you how to group the tables.
Another related question is, how does it scale in terms of, I don't know if it's actually for disk size, because you're joining all this into one physical record? So
each row, so look, this is the user, by the way, from the gaming company, and there's a whole bunch of information related to that user. So the user row will come right with all the other rows following it. So the total amount of disk space is exactly the same.
So if you have, say, something like a C union, right, it can have this piece or this piece. So now you're concatenating them into a single record, right?
No, each record is fully independent. So the record from here and the record related to it from all the other tables are fully independent records, just like before, just like in your regular MySQL. They just happen to be in the same space. Happen to be, which gives you all the benefits. You never have to join them again. But each row is independent. If you transact on a row, it's that row that you transact upon. All the other ones don't change. It's almost like in your mental kind of picture. Think about, so I have a table, and I can put different types of rows in it. And I just organize them in a smart way, based on how you use them. Does that help?
What about documentation? Providing documentation on this?
These guys are doing a lot of work on it. Yep, it's already up. I think it's already up on the website. Yep.
So your idea is just like a printer or reference. You doesn't. I mean, you don't increase the amount of data. You just put those reference based on some relation into a new data structure.
Correct.
And then this speed up the query very much.
And your object access. Exactly.
But how about the database writing intensive programs?
Great question. So it's funny because over the past year, this has been a recurring question in our web answers. Heavy loads about 1.5 times faster than the end. For your transactional load. Loading data, we will load slower, up to 2 times slower. That is the first time we load the data. Now, why? A transaction, your user, right? When he logs in, there's a bunch of things that happen on him. He logs in, so there's a login record. He changes something. He does another transaction. He meets another user. All of these tables change. That all goes into one place. Right? So your transaction is very localized. So transactions become very fast. Loading the data means that we need to interleave it. Unless, of course, you loaded it like JSON documents, for example, in which case that interleaving is already embedded in the document. But literally, when we deploy with MySQL, and the first time you load the data, because MySQL dumps it in table order, it'll take more time to load. And from that moment on, I think I actually have some examples of that. So this is loading from a pretty large website replicating over 24 hours. You see the spike in people's activity as they come back home. What you see here is tracking us and Eno in terms of how fast we can replicate. So because of that transactional locality, that becomes much, much faster.
Okay, before we go on more questions, just a few people came in later. Anyone that didn't get a 4 gig memory stick, courtesy of Akiban, just pick a color. You came in later. Would you like green or white? Oh, I'm sorry. I seem to have lost the cap. You came in green or white? Okay. White? Okay, purple.
I go with
half, there's more.
It's all right. Hopefully it survived.
Any more? Okay, yeah. Green or white?
White or green, both.
You got white. Unfortunately, there are no more whites. There's only green left. Green. Green.
Green or green?
Last one. Everybody got? Cool. That one's mine.
You should see the next batch of presents that Eric has in mind.
Oh, we got mugs. Speaking of which, if anyone wants the mugs, they're outside. Beautiful Akiban mugs.
So, have you guys seen examples like that? You guys are DBAs? I figured over there? No? Yeah.
There's no special DBA.
Yes.
This isn't a fair question, just we'll take it offline, but I've been recently looking at Google App Engine, and what's interesting about that is you have to define your queries up front, and I believe they use that to pre-populate hash tables. It sounds a little bit similar in the way that they're sort of co-locating and making the pointers ahead of time for fast. So really, there aren't any queries at runtime. They're all pre-computed in a sense. So that's
very much like the couch approach, right? Which is defining queries ahead of time, and then we'll keep those materialized views, really those result sets, updated. We don't approach it that way. You can run any query that you want. In fact, that's exactly where we bring the biggest benefit. You don't have to predefine them. You can, if you give us a slow query log or just a query log, that will allow us to recommend a grouping, but beyond that, you can run any query that you desire.
Yes. So large tables in MySQL, the alter table statement is miserable, right? It makes the full copy of the table, alters that, and switches the reference.
It's miserable.
It's still going to be miserable here, I would assume, but for alter tables. But what about altering the groups? Can you speak to both?
It's going to be miserable as long as you replicate. Don't replicate using standalone, and suddenly I'm not in MySQL crazy world. Changing groups is pretty straightforward, actually. So the simplest form is, say you want to extend your schema, right? Your user, you just want another piece of information about your users. Just add a table. You want to take away a piece of information, drop the table. Those are very, very efficient. If you want to completely change the structure of your schema, of your group, for example, you want to decide that this table doesn't belong in group A but in group B, right? Like that many-to-many relationship, then pulling that will incur copying. And that's as expensive, basically, actually more expensive than just copying a table in MySQL. We could have optimized that a lot, and in the beginning we thought we should. We just haven't encountered the user that changes his schema very often, and when they do, it's a big deal because your application changes dramatically, and in those cases they have a whole procedure to go into production. So it hasn't really been an issue, but the very basics of, say, think about the schemaless databases, and part of the glitch is, well, I can put any object in there, and it's going to work just fine. Well, if you could just put any object in there and it just expands the schema, you would get that benefit, except you could actually know what you have in there and ask the questions. So that's the approach that we want to take. So by the time you put your hand on it, you just push a JSON object, and you decide, okay, do I want to extend my schema based on this object in the default, or do I want to not and say, hey, it doesn't fit the model that I have. So, yes.
Okay, so my question is about the clustering key.
Yes.
And you give us an example using month.
Yes.
That's very clear. But if in some cases it's not clear which key I should use for that clustering key, and if I use the wrong key logically, will that greatly adversely affect the database performance?
You won't get the performance boost. It won't deteriorate, but you won't get the performance boost. If you chose the right key, you would get it.
But
so
if I choose the wrong, later on I found out, okay, I chose the wrong.
Oh, then we'll just change it.
But before I change that, how
you don't get any performance improvement.
But will I get the penalty? The penalty for that?
Probably in some cases, but not in any severe way. I will give you a sense of, okay, so how do I figure out this clustering key? Look at your application, look at your queries. If there's this predicate that always comes in, like app ID equals this, or you always look at information by month. Whatever you naturally write the queries with is going to be your clustering key.
Do you think it's possible to implement a mechanism to automatically set or configure?
Yeah. So I mentioned before that part of what we do is we recommend to the DBA, hey, this is a grouping that you should really consider based on your load, but we leave the final decision to the DBA. In the same way, we should probably do the same recommendation. We don't do it today. I think is a great idea. Because we see all those queries come in, and we see the commonality between them. That will immediately give you what that key should be.
Questions?
Are you thinking of a cloud-based solution?
He beat you to it, but you don't know your next. Is there a cloud-based solution for?
There will be. There isn't right now, and the open source is really what's going to come out. There was another question that I actually forgot to answer.
What are some of the disadvantages of a clustering? What will be the case when you want to use that?
So some applications don't have a natural clustering key. So I'm trying to think about it. It's not that easy. The biggest example is social networks don't have a clear distribution. A dating website, for example, is a social network, but if you think about it, people look for other people in their region. So immediately you get very close proximity and very close distribution that you could use. But probably in Facebook's case, there is no natural distribution scheme, right? So it's just taking that to the extreme. Or if you have just a financial application, probably there's no natural distribution beyond the fact that it works on whatever the company or the person or whatever it is that you use. So it's really per application. There was also the question about JSON and how to get it updated. So we don't store data as JSON internally or JSON or one of the variants. We store data as compact as possible so we can process it efficiently. But when you actually write the queries, you can specify how you want the results back. And that's important because a relational system allows you to get back tabular results, right, tables. But here you can get more complex structures, right? You can get JSON or XML hierarchies, whatever you would like. So it's just a way to specify this is the format that I'm interested in, and that will be the format that your data will be delivered in. So you can just specify, I don't want it as rows, I want it as JSON.
Next question?
Yes.
When we were talking about rights to the Akiban server,
yep.
Was there like how does the rights compare to if you have like a multi-core system? Like, what is the, I guess, optimal number of cores you could recommend for the maximum rights? Maximum efficiency.
So the system is, if I get the drift of where the question comes from, the system is not designed with a single-threaded, high-velocity write. It's at MVCC and ASIC. So what that means is that it scales pretty well across cores. It also needs to, multiple cores can write. You can have multiple versions of a piece of data, and multiple readers can read at the same time. So you can actually have multiple cores writing at the same time. Most of what we work with right now are 8 and 12 way core, 8 and 12 core systems, and it scales pretty nicely, and we haven't stressed the limit. So when the 48 core machines become really cheap, probably put an order in and let you know. But right now, that's kind of the range that we're focused on. And when we work with most of our design partners, that's pretty much the range that we see the machines coming in. A few hundred gigabytes, 12, 16 cores. That's kind of becoming the standard hardware that we're seeing out there.
Next question. All right, well, I want to give a great big round of applause.